Hello, this is video section 8.3, video notes and video on graphing reciprocal functions. So again, we've been graphing different kinds of functions and there's a pattern. We have a transformation equation that we use. But first let's identify what our function that we're going to be doing here. What is a reciprocal function? And that's our first vocabulary word. Well, let's look down. So we have to know the definition of what a reciprocal function. So basically, it's a function with the form of, excuse me, let me get back here, in the form of f of x equal 1 over a to the x prime, where a of x is a linear function and a of x cannot equal 0. So remember, a of x is a fancy word, kinda, for y, but the prime means we'll look at the parent function in just a second. So when you have an equation in this form, this is called a reciprocal function, right? It's reciprocal of x, basically, is what it is. Because x is x over 1, the reciprocal is 1 over x, okay? And a of x, which is your equation or polynomial in the denominator, is going to be a linear equation. And we've been graphing, since Algebra 1, linear equations. Those are just straight lines. So let's not get hung up on the fancy words. So now let's look at the parent function. This key concept box is really, really important that you know this and take notes on here. So the key concept box tells you what is our parent function. The parent function is f of x or y equals 1 over x. This is what the graph looks like. We said the denominator can't equal 0. It's a fraction. What happens when it's 0? It's undefined. So we need to find out those restrictions. It's undefined at whatever x is at that value. Okay, this type of graph is called a hyperbola. It looks like two exponential functions, a decay over here, and then one going the inverse of it. So they're just inverse kind of exponential equations, decay equations, or logarithm equations, or natural logs. So they have that quadratic parabola type shape U, but it's sideways at a diagonal. Okay, so what is the domain and range? So they give you fancy words, all non-zero. So what they're saying is the domain, if you look, it has asymptotes, and we'll talk about those in a second. It's y equals 0 or x equals 0, the y-axis. So it approaches the y-axis but never touches it. So other than that, it's all real numbers except for when x equals 0. What's the range? Again, it's got a horizontal asymptote as well at y equals 0, so it's all real numbers except for 0. What are the asymptotes? X equals 0 and y equals 0 for the parent function. Do they have any intercepts? Do they cross the x or y axis? No, not the parent function. It can, but not the parent function. And we said it's not defined as 0. So it's really important to look at this. So let's look at this. Domain of reciprocal function is limited to the values for which the function is defined. So look at this function here. The domain is limited to where it's defined. So we have to take the denominator, which is x plus 2, and find out when does it make that function undefined. Well, how do we know that? Well, I need to know when does x plus 2 equal 0? At what value is x? Does it make this expression 0? So I set it equal to 0. I use my algebra, and I get at x equal negative 2. So it's undefined at x equal negative 2. So that is going to be when it's undefined. Look at this one, x minus 5. Again, I have a variable in the denominator, so I set it equal to 0, and I get x equals 0. So the graph is defined at x equals 0. Or, 5. I did bad math here. X equals 5, because we plus 5 to both sides. I just used the algebra. All right, look at this next one, x. Well, we set it equal to 0. There's nothing to solve for, so it's undefined when x equals 0. So let's example 1. So look at the limitations of the domain. We have to limit the domain. So determine the value of x for which f of x, or y, equals 3 over 2x plus 5 is not defined. Well, because I have a variable in the denominator, I take that denominator, 2x plus 5, and I set it equal to 0. So I'm going to minus 5 from both sides. I'm just using basic algebra. Divide by 2, and I get x equal negative 5/2. So it is undefined at negative 5/2. I left that negative off there. Okay, so that's the first thing we do. Second, graphs of functions may have breaks in continuity. For excluded values, some may have asymptotes. You might have a hole in your function. And we'll learn more about holes later in a different section, but they're just telling you can have breaks. So let's look at example 2 and just go straight to how do we determine the properties of these functions. All right, so example 2 says identify the asymptote and the domain or range of each function. Again, you can follow along here. So let's look at it. They give us both the graph and they give us the function as well. So we see it looks like both this part and this part's approaching the x-axis, which would determine that we have an asymptote at y equals 0. That would be a horizontal line, yes? And then we also looks like it's going, what, 1, 2, 3. It looks like it's approaching 3 from both sides. So that would determine that we have a vertical asymptote at x equals 3. Because it looks like the graph is approaching this. And same thing here. It's approaching this line and this line. Now the asymptotes of a reciprocal function are going to intersect at hk. Okay, so here now if we look at the equation, we find out when is it undefined. Well, when we set the denominator set to 0 and we get x equals 3, so it's not defined at x equals 3, which must mean it's an asymptote. And if we go back to our key concept box, we know that the asymptote is at x equals 0 for x equals 0 because there hadn't been any transformations yet. Okay, so there's a vertical asymptote. Now you see as x decreases, goes this way, f of x approaches 0, but it never seems to touch it. And when you go this way, as x increases, f of x also approaches 0, which tells us that the domain is all real numbers except for when x equals 3, and the range is all real numbers not equal to 0. Let's look at the next one. And we'll notice it more with transformations. So we have g of x equal 1 over x plus 2 minus 1. Well, it looks like it's been, translated to the left 2 units. So it looks like my asymptote, when is it the bottom denominator undefined, when we set equals 0 at x equals negative 2. So that's my vertical asymptote. My horizontal asymptote, it shifted down 1 unit, so is my horizontal asymptote, because the parent function is y equals 0. So this is going to be y equals negative 1. And the domain is going to be all real numbers except negative 2. And the range is all real numbers except negative 1. Okay? Because of the asymptote. All right? So let's move on to transformation. So again, this key concept box is really important to know. Now, I'm adding a thing just like I have been doing to the transformation equation. So on your paper, you're going to put in a over c times x minus h plus k. So remember, our parent function is going to be 1 over x. Okay, so again we have a and we have c We have h and we have k. Now what we don't have from that we had in logarithms and exponential is b, because that has a base of b. This doesn't have a base, so we don't have b. But a tells us dilation and reflection vertically. C tells us dilation and reflection, but horizontal. Okay. H tells us it shifts right or left. H, translation. K is also a translation. It tells us up or down. Again, this affects the x-coordinate, y-coordinate, and y-coordinate. Now, we don't have 3 points like we did on logs and exponential. But this tells us the same thing. When the absolute value of A or the absolute value of 1 over C are greater than 1, we have a stretch. A is vertical and C is horizontal. When the absolute value of A and the absolute value of 1 over C is less than 1 but greater than 0, that means we have a compression. But we have to determine, is it vertical or horizontal? Well, A is vertical and C is horizontal. H, when it's positive, it moves up. To the right. And it moves to the left when it's negative. Likewise, K goes up when it's positive and down when it's negative. So let's look at a graph and transform it. So look at example 3. It says graph each function and state the domain and range. Well, first of all, let's identify what is A. A is 2, C is 1, H is 4. Remember, it's always x minus h, so you put that in parentheses, it's 4, and K is 2. So tell me, it has a vertical stretch of 2, it moves to the right 4, and it moves up 2 units. Okay, so guess what? My domain and my range changes, and so does my asymptote. So now my asymptote from x equals 0 goes up 2 units. So your asymptotes, vertical is x equal h, just like before on the other graphs, and the horizontal asymptote is f of x, or y equals k. Now this has 2 asymptotes instead of 1. The exponential and the logs only had 1, but this has 2. So they're going to translate up. So h is 4, our vertical asymptote is x equal 4, and we also see it's asymptote because we set the denominator x minus 4 equal to 0, and it's undefined at 4. Likewise, our horizontal asymptote is y equals 2. All right, so it approaches it but never touches it. All right, let's try this next one. So we identify A as negative 3, H is negative 1, and K is negative 4. So we know it moves to the left 1 unit and down 4 units. However, we have a vertical reflection, which means it reflects over this x-axis. So before it was right here and right here. When we fold it in half, this reflects over this line, so it moves up here. This one reflects over this line, so it moves down here. Now, my domain is still all real numbers except for x equal negative 1. And my range is all real numbers except for when y equals negative 4. So just like the asymptotes, that's what the domain is restricted to. All right, so you do it the same way. You just have to know the rules and the properties of the transformations. Identify A, H, and K, and C. This book is not going to give you any C's, but remember we said it has to be in factored form. If it's CX minus H, or CH, you have to divide both by C, and you get X minus H. It won't affect your C, but it will affect your H. All right, do the homework problems, and we'll see.